Hi friends, good evening. Welcome to my channel, Belagali's class. Friends, in differentiation, we are doing with 2-mark examples. Already I have done the varieties of examples, 1 mark, 2 mark also. Today I want to do few more examples under 2 mark questions. One sample on product rule. I am making use of what? Product formula. One example I do, 2 examples you can do yourselves. Then I do some 3 or 4 examples on inverse trigonometric functions, my friends. These are purely under 2 mark questions. Yes, friends. This is the first example. Find d2y by dx2 if y equal to e to the power 6x into cos 3x. E to the power 6x into cos 3x. It is a product formula. So, given y equal to this, differentiate with respect to x. Derivative of y dy by dx equal to d by dx of RHS. While differentiating this, you have to make use, my friends, product formula. First function as it is into derivative of cos. Derivative of cos is minus sine 3x. Angle is other than x. Right, its derivative. Derivative of 3x is 3 plus. Keep cos 3x as it is. Differentiate e to the power 6x. Derivative of e to the power 6x as it is. Power of e is other than x. Right, its derivative. Derivative of 6x is 6. Then e to the power 6x. E to the power 6x. It is common. You are left inside. Minus 3 sine 3x plus 6 cos 3x. Differentiate again with respect to x. Again, product formula. First, derivative of LHS. D by dx, you are differentiating first derivative with respect to x. Then derivative of first derivative is what? Second derivative. Symbol is d2y by dx2 or d square y by dx2. Again, while differentiating this, my friends, e to the power 6x as it is. Derivative of this bracket minus 3 into. Derivative of sine is cos 3x. Again, angle is what? Other than x. Right, its derivative. Plus 6 into. Derivative of cos is minus sine 3x into 3, my friend, here. 3. Plus. You keep this bracket as it is. Minus 3 sine 3x plus 6 cos 3x into, you are writing the derivative of e to the power 6x. Which is e to the power 6x into 6. Again, my friend, here, derivative of first derivative is second derivative. Symbol e to the power 6x. E to the power 6x is common. You are left here minus 3 into 3 minus 9 cos 3x plus minus 6 into 3 minus 18 sin 3x. Next, my friend, this is taken out. It is 6 into minus 3. 6 into minus 3 is minus 18 sin 3x. And this 6 into 6 plus 36 cos 3x. Yes. It is minus 9 plus 36. Left with plus 27 cos 3x. Minus 18 minus 36 sin 3x. This is the wanted d2y by dx2. So, even if you wanted, you may take what? 9 common here. If you take 9 common here, you are left with 3, you are left here 4. That is, depends on you, otherwise even you can keep as it is. So, in this case, it is a product formula. Making use of the product formula, first derivative. Again, product. First function as it is. Derivative of cos 3x minus 3x into 3 plus this cos 3x as it is, derivative of e to the power f, it is e to the power f. What is the power other than x? Write the derivative of 6x, 6, 5. You know this formula, which one? Derivative of kx with respect to x is, my friends, it is k. Kx is k, 6x is 6, 3x is 3. Yes. Again, e to the power 6, e to the power 6 common, this is left inside. You wanted the second derivative. To get second derivative, differentiate again with respect to x. E to the power 6x into, yes, you are writing derivative of this, minus 3 into derivative of sine cos 3x into derivative of 3x is 3 plus 6 into derivative of cos is minus sine 3x into derivative of 3x is 3. Yes, you have to simplify, my friends. This is 3. Again, you are keeping this bracket as it is. You are writing the derivative of e to the power 6x, e to the power f, e to the power f into f dash, derivative of power 6x is 6. Then e to the power 6, e to the power 6 common. Minus 3 into 3, minus 9 cos 3x, minus 18 sin 3x. Again common, 6 into minus 3, minus 18 sin 3x, 6 into 6, plus 36 cos 3x. Yes, minus 9 plus 36 plus 27 cos 3x. Minus 18 is minus 36 sin 3x. This is the answer, my friends. I have done one sample, another two samples, simple examples. Y equal to x cube log x, y equal to x sin x. These two examples, my friends, you do it yourselves. In this case also, find d2y by dx2. Find d2y by dx2 if this is 1, this is second. Do them, my friends. Even these also comes under what? 2 mark questions. If you do correctly first derivative, dy by dx, you get 1 mark. If you write correctly the second derivative, d2y by dx2, you get what? The second mark. Yes, my friends. It is also one sample on product formula. Yes, my friends. Next, you may have some 3-4 examples on inverse trigonometric functions. Differentiation of inverse trigonometric functions. Just I have reminded some results here. Derivative of sine inverse x, 1 by root 1 minus x square. Instead of sine, my friend, if it is cos here, only change is minus here. Cos inverse x is minus 1 upon root. Tan inverse x, 1 by 1 plus x square. If it is cot inverse x, it is minus 1 by 1 plus x square. That trick you must remember. Derivative of any trigonometric ratio, whether it is ordinary or inverse, the trigonometric ratio that starts with the letter C. Letter C have negative sign. Letter C have negative sign. Negative sign. Cot inverse minus 1 upon 1 plus x square. It is also a property done in case of what? Inverse trigonometric functions. Sin inverse sin theta equal to theta. Tan inverse tan theta equal to theta. Same. Cos inverse cos theta equal to theta. Sec inverse sec 2 theta. 2 theta. Cosec inverse cosec 3 theta. 3 theta. That angle itself. This, my friends. These are the formulae done in PUC first year. These are done in PUC first year, my friends. This formula. These are done in PUC first year. Sin 2 theta in terms of tan. 2 tan theta upon 1 plus tan square. Cos 2 theta. 1 minus tan square upon 1 plus tan square. Tan 2 theta. 2 tan theta upon 1 minus tan square. All these are the properties connected with inverse trigonometric functions, my friends. Inverse trigonometric functions. Next, I do just 3 or 4 examples of inverse. Find dy by dx if y equal to sin inverse 2x upon 1 plus x square. Y equal to sin inverse 2x upon 1 plus x square. My friend, this also comes under 2 mark question. It is also a good example. Under 2 mark, good example. So, we want to make use this formula. 2 tan theta upon 1 plus tan square is sin 2 theta. For that, you have to put what? X equal to tan theta. Put x equal to tan theta. So y is sin inverse, we are putting here. Sin inverse, x is tan. So 2x, 2 tan upon 1 plus x square, 1 plus tan square. This is by this formula. What is it? Sin 2 theta. So sin inverse of sin 2 theta by this formula. Sin inverse of sin theta is theta. By this formula, what is it? 2 theta itself. 2 theta itself. Sin inverse of sin is 2 theta. But what is theta? X is tan theta. Bring tan this side. It becomes tan inverse x equal to theta. This gives, taking tan this side, tan inverse x equal to theta. Substitute theta tan inverse x. Therefore, y is tan inverse x. Differentiate with respect to x. Derivative of y, dy by dx. Derivative of tan inverse x. Derivative of tan inverse x is 1 upon 1 plus x square. 1 upon 1 plus x square. This, my friends. So I do some 3-4 examples. In all these, substitution for x is tan because to use this formula. Use this formula. Sec is what? Reciprocal of this. Cos 2 theta is this. Sec 2 theta is 1 plus tan square upon 1 minus tan square. Cot 2 theta is reciprocal. Cosec 2 theta is reciprocal, my friends. Yes. Substitution, sin 2 theta. Sin inverse of sin 2 theta is 2 theta. From this theta is tan inverse x. Then derivative 2 theta, 2 tan inverse x. 2 tan inverse x. Therefore, this is 2 into, and this is 2 into 1 upon 1 plus x square. Now, if you simplify this, this gives 2 upon 1 plus x square. 2 upon 1 plus x square. Hope it is clear, my friends. Clear. Like this, you have another 3 or 4 examples. I will do on inverse map. All this comes under 2 mark questions. 2 mark questions. Next, making use of cos 2 theta. The next, making use of what? Tan 2 theta. Yes, my friends. Yes. Yes, friends. So the next example is what? Making use of this formula. Cos 2 theta equal to 1 minus tan square upon 1 plus tan square. Come from RHS to LHS. If it is 1 minus tan square upon 1 plus tan square, by this formula the value of RHS is LHS, which is cos 2 theta. Cos 2 theta. Yes. Find dy by dx if y equal to. Find dy by dx. Find dy by dx. Yes. I see, because we are making use of this formula, my friends. This formula. Put x equal to tan theta, then taking tan this side, it becomes tan inverse x is theta. Y equal to cos inverse. X is tan 1 minus tan square upon 1 plus tan square. But 1 minus tan square upon 1 plus tan square. 1 minus tan square upon 1 plus tan square is cos 2 theta. Cos 2 theta. This is cos 2 theta. Again, cos inverse of cos. Cos inverse of cos, making use of this property. It is 2 theta. It is 2 theta. But what is theta? Tan inverse x. So, differentiating derivative of y is dy by dx equal to 2 into derivative of tan inverse x is this. 1 upon 1 plus x square. 2 into 1. 2 upon 1 plus x square is the answer. Sometimes, instead of this, my friends, cos inverse 1 minus x square upon 1 plus x square, the friend examiner may give y equal to sin inverse 1 minus x square upon 1 plus x square. But remember, in all these cases, your x is what? Tan theta. Then tan inverse x is theta. Substitute y equal to sin inverse 1 minus tan square upon 1 plus tan square. Again, you are putting its value. What is 1 minus tan square upon 1 plus tan square is cos 2 theta. Yes, my friend, you are writing this as what? Cos 2 theta. Now, this side is sin inverse, but this is cos. And to make use of the property, both must be said. Sin inverse of sin theta, then only it is theta. Under the conditions only. In that case, what? that theta must lies between minus 90 plus 90. Under that conditions, all properties are true. Even in this case also, where is theta? It is also what? Between minus 90 plus 90. Those conditions are there always. Yes. It becomes sine inverse of cos 2 theta. Then we want to make this cos sine. If we change from cos to sine, you have to replace the angle by pi by 2 minus the angle. Pi allied angle formula. 90 change. Then 180, no change like that. Allied angle. When that is also done at where? You see, first year level. At that time, allied angles, everything we have done. Yes, my friends. Same thing. Sine inverse of cos. Change cos to sine. In that case, replace this angle 2 theta by pi by 2 minus 2 theta. Sine pi by 2 minus theta. Pi by 2 means sine changes to cos. Angle is in the first quadrant positive. So now it becomes sine inverse of sine. Angle itself. Pi by 2 minus 2 theta. Pi by 2 minus 2, what is theta? Tan inverse x. Therefore, dy by dx, derivative of constant pi by 2 is 0, minus 2 into derivative of tan inverse x is 1 upon 1 plus x square. So what is the answer? Minus 2 upon 1 plus x square. Minus 2 upon 1 plus x square. When it is sine with cos. When it is cos with cos, sine with sine, tan with tan, it is only 2 upon 1 plus x square. If they are mixtures, in that case it is minus 2 upon 1 plus x square. Same, it is sine inverse 1 minus x square upon 1 plus x square. But it is cos inverse 2x upon 1 plus x square. And this 2 tan theta upon 1 plus tan square is a formula for sine. And 1 minus upon 1 plus is formula for cos. If you get a sine cos or cos sine, to change it from cos to sine, replace the angle by pi by 2 minus 2 theta. Same thing here. Yes. First, put x equal to tan. Tan inverse x is theta. So y is cos inverse x is tan. 2 tan theta upon 1 plus tan square. 2 tan upon 1 plus tan square is sine 2 theta. Sine 2 theta. Again see, different. Convert sine to cos. If you convert sine to cos, replace your angle by pi by 2 minus 2 theta. Replace angle by pi by 2 minus 2 theta. Again cos inverse of cos. Pi by 2 minus 2 theta. Anyway, it is an angle where between 0 to pi, 180 degrees. Therefore, apply that property. Cos inverse of cos is that angle itself. So, pi by 2 minus 2 theta, which is your y. Put the value of theta. Theta is tan inverse x. It becomes y is pi by 2 minus 2 tan inverse x. Differentiate with respect to x. Differentiate with respect to x. Derivative of y divided by dx. Pi by 2 being a constant, derivative 0. Minus 2 into derivative of tan inverse x is 1 upon 1 plus x square. Simplify. Minus 2 upon 1 plus x square is dy by dx. Yes, my friends. These two are with sine cos. I do one example connected with tan inverse, my friends. Tan inverse. Copy it, I give 1 minute. Same example, same type, my friends. Same type. Yes, my friends. So the next example is it is tan inverse y equal to tan inverse tan inverse 2x upon 1 plus 1 minus x square, not plus, minus. Then find dy by dx. Find dy by dx. Same, x. tan theta. Y is, it is tan inverse of tan, it is tan inverse of 2 tan theta. 2 tan theta upon 1 plus tan square. 1 plus tan square, which is tan inverse of tan 2 theta. Tan 2 theta. Tan inverse of tan 2 theta is 2 theta. Theta is tan inverse x. Differentiate this, my friend. This. It is with tan inverse. Tan inverse. To mark means they give some simple examples. Friends, I have done with tan inverse 2x upon 1 minus x square. It is the next. If y equal to tan inverse 3x minus x cube upon 1 minus 3x square, where x lies between this and this, then find the dy by dx. Then find dy by dx. Dy by dx. Yes. So in this case, you have to make use what? Formula for tan 3 theta. Tell anybody else? Formula for tan 3 theta. We have done QC level. It is 3 tan theta minus tan cube theta. Down is 1 minus 3 tan square theta. 1 minus 3 tan square theta. This formula we are making use here, my friends. To get it same again, put x equal to tan theta. Then tan inverse x is theta. Substituting here y equal to tan inverse 3 tan minus tan cube upon 1 minus 3 tan square, which is this, my friend, because of this tan 3 theta formula. Tan 3 theta. So it is tan 3 theta. Tan inverse of tan 3 theta is 3 theta. It is 3 into what is theta? Tan inverse x. 3 tan inverse x. So y equal to 3 tan inverse x, differentiating gives dy by dx equal to 3 into derivative of tan inverse is 1 upon 1 plus x square. Simplify 3 upon 1 plus x square. It is also a good example under 2 mark, my friends. 2 mark. In this case, you have to put x equal to tan theta and make use this formula. 3 tan theta minus tan cube upon 1 minus 3 tan square is tan 3 theta. All these are proved formula we have done at QC 1 level trigonometry. QC 1 level. So, to get it, you have to put again what x equal to tan. Tan inverse x is theta. Substituting in y, tan inverse 3 tan minus tan cube upon 1 minus 3 tan square. This is nothing but tan 3 theta formula. Tan inverse of tan 3 theta. Put the value of theta, tan inverse x. So, y equal to 3 tan inverse x. After differentiating, dy by dx equal to 3, derivative of tan inverse x is 1 upon 1 plus x square. So, the answer is 3 upon 1 plus x square. Then these two examples connected with sine and cos inverse. 7th, if y equal to sine inverse 2x into root 1 minus x square, 2x into root 1 minus x square, where x lies between minus 1 by root 2 less than 1 by root 2, less than 1 by root 2. So when x lies between, that means what about your theta? Minus 45 to plus 45, which is, we can make use here. We can make use. Sine inverse of sine 2 theta, theta lies between minus 45 to plus 45. Put x equal to sine theta. Then find the value of root 1 minus x square. Root 1 minus x square means sine square. What is 1 minus sine square? Cos square. Square root of cos square, cos theta. Square root of cos square is cos theta. Substituting these values in y, sine inverse 2 x is sin theta, root 1 minus x square is cos theta. It is 2 sin theta cos theta. Once again, multiple angle formula. 2 sin theta cos theta is what? Sin 2 theta equal to 2 theta, because theta lies between minus 45 plus 45. Yes, 2 theta. Put the value of theta. X is sin theta. X is sin theta. Taking sine this side, sin inverse x equal to theta. This step, sin inverse x equal to theta. So y becomes 2 theta. Theta is sin inverse x. dy by dx, 2 into derivative of sin inverse x is 1 by root 1 minus x square. 2 into derivative of tan inverse 1 by root 1 minus x square, which is 2 upon root 1 minus x square. 1 minus x square. This is 8th one. It is connected with what, my friends? Cos inverse. Y equal to sec inverse 1 by 2x square minus 1. 2x square minus 1, where x lies between 0 and 1 by root 2. Yes, you have to make use of this property. Sec inverse x is cos inverse 1 by x. To convert sec inverse to cos inverse, replace your x by its reciprocal. Same, cosec inverse x, sin inverse 1 by x, cot inverse x, tan inverse 1 by x, like that, my friends. Convert from sec inverse to cos inverse, reciprocal. Put x equal to cos theta. Theta is cos inverse x. Put x equal to cos theta, taking cos this side. Cos inverse x is theta. Substituting y equal to cos inverse 2 cos square theta minus 1. Again formula cos 2 theta. 2 cos square theta minus 1 is cos 2 theta. Once again, cos inverse of cos 2 theta is what? 2 theta, as theta lies between 0 and 45 degrees. 45 degrees. So, you have to go for what? Substitute the value of theta. Theta is cos inverse x. Therefore, y equal to, my friend, y equal to 2 cos inverse x. Differentiate dy by dx equal to 2 into derivative of cos inverse. C means negative side. Minus 1 by root 1 minus x square. This is sin inverse with plus sign. This is cos inverse with minus sign. Both are same with a sign change. Simplifying, minus 2 upon root 1 minus x square. My friends, hope clear. Y equal to sec inverse of what? 1 upon 2x square minus 1. X lies between this. So, in this case, apply first this. Sec inverse is cos inverse 1 by x. Convert sec inverse to cos inverse, taking the reciprocal. X is cos theta. 2 cos square theta minus 1 is cos 2 theta. Cos inverse of cos 2 theta is 2 theta. Theta is cos inverse x. So, derivative 2 into cos inverse means minus 1 upon root 1 minus x square, which is minus 2 upon root 1 minus x square, is dy by dx. Similar, y equal to sec inverse 1 plus x square upon 1 minus x square. Convert from sec inverse to cos inverse. What is cos inverse? Reciprocal. 1 minus x square upon 1 plus x square. This example just previously done. You have to go with what? Put x equal to tan theta and all. Same done in the previous, just 2-3 examples back it is done. All these, my friends, these are the examples of inverse trigonometric functions. Inverse trigonometric functions. Even these examples are also important under 2-mark questions. Yes, my friends, these with inverse. Then one more variety is left. This also comes under what? 2-mark question. This example I have taken at what? This is 10th example. Differentiate one function with respect to another function. All these already we have done. I have collected and done only for what? Examples under 2-mark questions, my friends. I hope it is copied. Yes. This example is differentiate x square with respect to x cube. It is also what? A 2-mark question. 2 mark question. Differentiate x square with respect to x cube. Method, let u equal to first function, phi equal to second function. Now you have to find the derivative of u with respect to phi with respect to phi. First you have to find du by dx. Derivative of x square is 2x. Phi x cube. Derivative of phi with respect to x is derivative of x cube with respect to x, 3x square. This is the formula. Du by dv equal to du by dx upon dv by dx. What is du by dx? 2x. What is dv by dx? 3x square. 2x upon 3x square is 1x cancels, my friends. It is 2 upon 3x. Then what is the method? I will explain once again. Differentiate x square with respect to x cube. X square with respect to x cube. Take first u. Take second phi. Find its derivative with respect to x, du by dx. Derivative of x square with respect to x, dv by dx. Derivative of x cube with respect to x, 3x square. Formula, du by dv, du by dx upon dv by dx. Its value 2x, its value 3x square. When x is cancelled, 2 upon 3x is the answer. Now for your information, I do one more example. One more example. Yes, that example is relevant. Differentiate sine square x with respect to e to the power cos x. E to the power cos x. Differentiate sine square x with respect to e to the power cos x. 2 mark question. Same method. Let u equal to sine square x. Find du by dx. Power to 1 power less into derivative of sine x, which is it is 2 sine x into derivative of sine x is cos x. Don't use formula, keep it as it is. Next, phi equal to e to the power cos x. Differentiate dv by dx e to the power f as it is into derivative of power cos x. Derivative of power is cos x. So it is e to the power cos x into derivative of cos is minus sin x. Minus sin x. Yes, now use this formula. Use this formula. Du by dv equal to du by dx upon dv by dx. Substitute the values. Now, du by dv is du by dx upon dv by dx. Put the values. Du by dx is 2 sin x into cos x. This is 2 sin x into cos x. Down. dv by dx, e to the power cos x into minus sin x. E to the power cos x into minus sin x. Minus sin x. This minus sin is cancelled. Plus upon minus is minus. This minus. 2 is there. 2 is there. Cos x is there. If you lift this to the numerator, then plus cos x becomes minus cos x. Minus cos x. Yes, my friends, copy it. I will explain once again. I will explain once again. Right, copy it. Copy it. Yes, friends, this example is second 11. Differentiate sin square x with respect to e to the power cos x. First u, second phi. Differentiate with respect to x, du by dx, power 2, 1 less sin x to the power 1 sin x, other than x, derivative. Therefore, it is 2 sin x into derivative of sin x is cos x. Don't use formula because it cancels or seen it. Keep it as it is. Phi, d phi by dx, e to the power cos x. This is derivative of cos x. Derivative of cos x is minus sin x. Again formula, du by dv, du by dx upon dv by dx. Values are substituted. Sin is cancelled. Minus plus upon minus is minus. 2 cos x here. Denominator is this, so lift this to the numerator, plus cos becomes minus cos. It is the answer. If you have an interest, can just 1 or 2 examples you do at home. DIY. Differentiate e to the power x with respect to, or we can take 2x with respect to log 2x. Log 2x, like this, my friends. Like this. Yes, for example, DIY. All these examples, my friends, with the varieties I have done, trigonometric identities, implicit, explicit, then successive differentiation means second order derivative. Next, today I have done even with inverse, then even I have done with what? By making use of product formula. One example I have done, it is e to the power 6x into cos 3x. All these examples comes under 2 mark, my friends, on differentiation, 2 mark questions. So I have done 1 mark differentiation, I think 2 videos, and 2 mark questions I have done more than 2. It is what? The fifth one, all these examples what I have done. Nearly half an hour I have done the remaining type of all examples, my friends. Remember, in the 2 mark questions, model question paper, 2 mark, according to the model question papers, you have 3 questions. You have 3 questions. 3 questions. Normally, they have given 2 model question papers, my friends. Both the model question papers under this contains what? An example on implicit functions. Implicit functions, common example. I have done yesterday almost all the examples given in your textbook, my friends. Even remaining successive, sometimes they give out very earlier than even they have given successive one, implicit one, another one, like this. They give 3 questions under 2 mark questions, which is part B. Part B. In part A, my friends, part A means differentiation. It is a 1 mark question, only one example or one question. One question. 1 mark, one question in differentiation. In a differentiation. And 2 mark, 3 questions, my friends. I have completed differentiation, part A, part B, and even inverse trigonometric functions, both 1 mark and 2 mark I have done. Then I want to do it what? After this differentiation, I want to do examples under integration, my friends. Integration, both 1 mark and 2 mark questions. 2 mark questions on integration. Yes, my friends. Now I start with what? 1 mark question in integration. Yes, my friends. This is with differentiation, both 1 mark as well as what? 2 mark questions. Yes. Now I do some few examples of integration. 1 mark first. First, I will remind the list of the formulae. List of the formulae. Yes, my friends, after the completion of what? 1 mark and 2 mark examples in differentiation. Next, I want to do again 1 mark, 2 mark questions in integration. Integration, my friends. See, this is integration. In main exam, board exam, 1 mark you get 1 example, 2 mark you get 2 example, 3 mark 3 examples, 5 mark 1 question, 6 marks 1 question. Totally 8 questions. 3 plus 2, 5 plus 1, 6 plus 1, 7 plus 1, 8 examples. If you count the marks, my friends, these are around 25 marks. 25 marks. If you do only main things, it is not connected with area, differential equation, nothing. Only it is with integration. 1 mark 1 example, 2 mark 2 examples, 3 mark 3 examples, 5 mark 1 example, 6 marks 1 example, totally 8 questions. And the total marks is 25. Yes, my friends. First, I am happy as well as what you are also happy. Just if I remind the list of the formulae in case of what? Integration. That is the basic thing, my friends. Yes. See, I will start with definition itself. This is a definition of what? Important points. Definition of integration. If the derivative of gx with respect to x, is fx, reversing. Why? Integration is a reverse process of differentiation. Integration is a reverse process. Reverse process of differentiation. Therefore, it is what? Differentiation. Derivative of gx is fx. Reversing integral of fx. Integral of fx with respect to x is gx. So, integral of fx with respect to x is gx. Plus, say as usual, this is a constant of integration. Because of that, indefinite, definite comes. Everything you know, my friends. Here, this gx is called as antiderivative. Reverse process. Differentiation, antidifferentiation, antiderivative. Or integral of fx with respect to x. Integral of fx with respect to x. Rules of integration. 1. Integral kfx. What is k? Constant coefficient kfx. That k, which is a constant coefficient, can be taken outside integral sign, remains inside integral fx dx, where k is some constant. Second, integral of fx plus minus gx with respect to x is integral of first function, plus is plus, minus is minus, integral of second function. It is integral of first function plus minus second function is integral of first function. If there is a plus, you write plus. If there is a minus, you write minus. Integral of second function. These two rules. K can be taken outside. Plus is plus, minus is minus. Rules of integration. Then these are standard formulae, my friends. We have done all these things. Standard formulae. Integral of 1 is x. For every formula, I am not going to write. Sample I have written, plus c is there. If it is an indefinite integral, we have to write plus c. If it is a definite integral, no need to write plus c. K, constant. Integral of any constant is that constant multiplied by x. If it is 5x, integral of 5x. Integral of 10x. Integral of minus 7x, like that. Yes. Next is this. Integral of x to the power n n plus 1 upon n plus 1. As usual, that plus c. Rest I am not going to write that plus c. No. This is what other than x. Ax plus b to the power n. Ax plus b to the power n is what? Ax plus b to the power n plus 1 upon n plus 1. If x, only n plus 1. If it is other than x means what? You have a coefficient of x, then you have to divide by that coefficient. So it is what? Ax plus b to the power n is Ax plus b to the power n plus 1 upon n plus 1 into other than x. Write the coefficient of x. One sample example I have done. Even they may ask this example under 1 mark question. Find the integral of 5 minus 2x to the power 3 with respect to x. Same. Ax plus b, it must be linear. Ax plus b to the power 1 more. 3 plus 1 is 4 upon 4 into other than x. Right, into coefficient of x. Coefficient of x is minus plus c. It is 5 minus 2x to the power 4 upon minus 8 plus c. Then this side, integral of 1 by x, either log x or log mod x. It is other than x. 1 upon ax plus b, as usual, log ax plus b. If it is other than x, divide by the coefficient of x. It is 1 upon x to the power n. 1 upon x to the power n, sign change. Minus 1 upon n minus 1. If the power is n, it is 1 less. N minus 1 into x to the power n minus 1. For the x, power and coefficient they are same, which is 1 less to the given power. 1 upon root x, 2 root x. 1 upon root x is 2 root x. I have written all this at a stretch. This is one list. Then these are with exponential functions. E to the power x, e to the power ax. What is the power other than x? If it is other than x, write e to the power ax as it is. If it is other than x, divide by the coefficient. Coefficient of what? X here. Divide by a. A to the power x. A to the power x upon log a. Base is other than e. Divide by log of the base. These are trigonometric functions. Integral of sine minus cos. Integral of cos plus sine. Integral of tan log sec x or minus log cos x. Log sec x or minus log sec x. Cot x log sin x. Integral of sec square tan x. Integral of cosec square minus cot x. I told my friends, starts with a c as a negative sign, but in this case no, sign is minus cos. Then integral of sec log sec x plus tan x or it is log tan x by 2 plus pi by 4. X by 2 plus pi by 4. Cosec log cosec x minus cot x or log tan x by 2. In case of sec plus pi by 4. X by 2. In case of sec is plus pi by 4. Integral sec x into tan x is sec x. Integral cosec x into cot x minus cosec x. Yes, now the angle is other than x. Sin ax. What is the integral of sine? Minus cos, you have to write. If it is x, you write x. If it is other than x, divide by the coefficient. See, sine minus cos. Whatever the angle is given, you write it. Look, is it x? No. Other than x, write the coefficient. Means divide by the coefficient. Cos ax plus b. Integral of cos is sine. Whatever the angle is there, you have to write ax plus b. Is it x? No. Other than x means divide by the coefficient. Yes, my friends. This is the definition of integral, rules of integration. This is with algebraic functions. 1. K. X to the power n ax plus b to the power n 1 by x log x 1 upon ax plus b 1 upon x to the power n 1 upon root x to root x. These are exponential. E to the power x, e to the power x, e to the power ax, e to the power ax upon a, e to the power x, e to the power x upon log a. All these are with trigonometric. Sine minus cos, cos sine, tan log sec x or minus log cos x, cot log sine x, sec square tan x, cosec square minus cot x, sec x, log sec x plus tan x or log tan x by 2 plus pi by 4. Integral of cosec log mod minus cosec x minus cot x or log tan x by 2. Sec into tan sec x by 10 because derivative of sec is sec into tan. Cosec x into cot minus cosec because derivative of cosec is minus cosec into cot. If the angle is other than x in trigonometric functions, if it is other than x, divide by the coefficient. Divide by the coefficient. My friends, all these except two inverse functions. It is integral of 1 by root 1 minus x square is sin inverse x. 1 upon 1 plus x square is tan inverse x. Okay? Except that, I think my friends have written everything. I give 1 minute, man. Just to observe it. Observe it. Yes, my friends. My next plan is to first to do the examples under 1 mark question. Under 1 mark question based on this list of the formulae. Based on this list of the formulae. Yes, my friends. You must read repeatedly this list of the formulae and you must know the formulae in case of integrals. Then only you can able to do the examples in integration, my friends. Yes. Now I do examples based on this list. Under 1 mark questions first, later 2 mark questions. I'm not going to do all these 3 and 5 and 6. You know all these things. 6 definite integral theorem. 5 those rational, irrational. You know everything. Yes, my friends. Yes, my friends. Now, examples based on this list of the formulae. Instead of doing today with this video, I'm going to do those examples under 1 mark questions in the next class, or you can say in the next video. Yes, my friends. Based on this formula, I do in the next video, next class, my friends. Till then, namaste, namaskara, my friends. Namashinna. Enjoy. Have a good day. Thank you very much, my friends. Thank you.